Hello, Algebra 2 students. For Miss Bell, I'm looking at interpreting linear models, and we have some problems here that we're going to go through very quickly. Here we have a T-chart with the rank and the possibility and percentage if you're ranked in a basketball tournament, and the possibility of you winning your first game. Probability of winning your first game. So, and it's graphed over here, and you have this equation here that we're going to use in order to answer some of these questions. For part A, what does the slope of the line represent? So this slope of the line, it is decreasing, and it says, what I have written here, the probability of winning decreases as the rank increases. So if you're higher ranked, it would actually be lower. If you're lower ranked, like you're 10th in your league or whatever, you have a lower probability of winning your first game. If you're ranked high, like the second ranked team, high probability of you winning your first game. So it decreases as the rank increases. So it goes down about 20. Your probability goes down about 20 per 3 ranks, about 20% per ranks. Okay, that's a little percent there. Okay, B, what does the y-intercept of this function represent? And you could slow this down as I'm just going through this kind of quickly. So the y-intercept represents the probability of winning the first game at rank 0. I know that doesn't make much sense. You're not going to have somebody ranked at 0. It's going to be ranked number 1. But that's what the y-intercept would be when x equals 0. So the x values are rank. C, according to the model, a school ranked number 3 has the probability of winning their first game. What's the probability of that? Round your answer to the nearest percent. So all you're going to do is add a 3 into this equation, and then you're going to get 85% once you work that problem out. Same thing for letter D. You're going to figure out for ranked number 12. They have a much lower percentage, 29%, once you plug that into that equation. For the last one on this number, letter E, we have a 73% chance of winning their first game. What would their rank have to be? So 73% chance, that would be your y value. So now we're figuring out for x. So I subtract 104 from both sides, then I divide by negative 6.29, and I get 5 equals x. Try 2 on your own. It's the same procedure as number 1 and number 3. You have the same type of problem. You're just going to do the same operations just with the different numbers. You're going to answer them essentially the same too. Okay, so let's take a look at number 3 here. What does the slope of the line represent? So this slope is increasing, and we're talking about electricity in kilowatt hours and temperature. So the use of electricity is increasing as the temps rise, and it's going about 2 kilowatt hours. It's increasing 2 kilowatt hours per every 5 degrees Fahrenheit. What does the y-intercept of this function represent? Well, that would be when your temperature is at 0, so the electricity use at the temp of 0. Okay. C, using the model, how much electricity would be consumed if the average daily temperature was 76 degrees Fahrenheit? And we're going to round this. So 76 degrees Fahrenheit, I just plug that in for my x value. I work the problem out. This times this plus this, and I get 41 kilowatt hours. It was, I think, 41 point something low, so I rounded to 41. You do the same thing for 103, so that would be, off this chart, and they're predicting, a higher temp. So you just plug in 103 for that, this times this plus this, and you get 54 kilowatt hours would be used. And then the last one's a lot like the last one in number 1. It's going to be a lot like the last one in number 2 and in number 4. These are all following the same pattern. So just do the same thing for each one for 2 and 4 also. This is your Y value that they're giving you, 36 kilowatt hours, okay? Now you're going to solve for X. So I subtract 6.6 from both sides, and then I divide by 0.457. I get 64 equals my X, which is going to be the temperature, 64. And you could find that on there, and it should match up pretty well with your graph that's up here. Okay, hopefully this helps. And like I said, the evens are a lot like the odds. They're just using different numbers. Good luck.